Let's now talk about the gear mate and rack and pinion mate. Now using gear mate, you can show motion between different gear sizes. Now here in this case, in this assembly, as you can see, we have a big spur gear and a smaller one. Also we have a rack and pinion arrangement. So basically we'll create the motion between all of these three sets in such a way that if you move one of these gears, if you just rotate any of these, it's going to rotate the next pinion, which in turn will rotate, well, in this case, move the rack, or vice versa. So if you move the rack, this should rotate the pinion, and that should in turn rotate this spur gear. Now, to start this, I'll go to Mate and I'll select the Mechanical tab. Now right here, we have the Gear Mate. So select it. Now in this case, simply select the pitch diameter of two gears. If you have already created sketches that represent the pitch diameter of the gears, then you can select it right now. But in this case, we don't have it yet. So what I'm going to do instead is I'll simply select this shaft, or you can also select any other circular face here. So in this case, this shaft makes more sense. So I'll just select that. This will automatically select its diameter as the first ratio. And then if you select the second shaft, it will automatically select that diameter as the second ratio. Now, as I mentioned earlier, you should select the pitch diameter surface or the pitch diameter curve if you have already created it, but in this case we don't have it. So instead you can manually add a ratio, the ratio which we also call the gear ratio. And gear ratio is just the ratio of pitch diameter of both of these gears. So let's add it. Now in this case, we know that the gear ratio of these two gears is 9/4. So I'm going to type 9 and 4 here. So 9/4 is the gear ratio. Now with that, these two gears should show the actual motion. So now I'll click OK and OK again, and here we have it. Now let's see how it's going to work. So in this case, as you can see, these teeth are actually mating quite properly, so I don't need to change it. But if you start with gear where these teeth are not properly mated, then you need to first ensure that they look proper before actually adding these mates. In this case, we directly added mate because they were meshing properly. So now I'll just rotate this, and as you can see, with this rotation, the second one is also now rotating quite properly. So that's because of the gear mate. But now if you go back to this one here, this view, and look at this here, the rack and this pinion, they are meshing, well, not so properly. So this is not the way the gear should mesh in a real world situation. So what I'm going to do here is I'll first properly place it so that they don't mesh, and it should look like this. So physically they are not touching right now, and that's the way it should be. Once you've set it, you can now add the mates between this rack and this pinion. So let's try that. So after this gear mate, I'll go to mate again, and again mechanical, and now I'll select this rack and pinion mate. All right, now in this case, we need to start with rack and then select pinion. For rack, simply select the straight edge of the rack, which represents direction of motion. So this rack will move in this direction, and we can just select any edge, maybe this one on this rack, to represent that direction. Now for the pinion, again, you can select the pitch diameter, but once again, we don't have pitch diameter here. So I'll simply select this shaft. Now, since we have selected this shaft, so we need to compensate this with the actual value. We have selected it only to represent the direction of motion, but now I'm going to add actual pitch diameter. So it is 10 mm because of the shaft diameter, but if you know that, if you know the actual value, add it here right now. So the diameter is 57 mm, as we know that the pitch diameter for this pinion is 57. So I'll manually add it, and with the first option selected, which is pinion pitch diameter, simply click OK and OK again. All right, now let's see how it works. So I'll click on this normal 2, and let's now move it. So here, when I'm moving this rack, it is also moving this pinion, which in turn is rotating this gear. But once again, if you notice closely, we have a problem. Well, these two teeth are meshing, and again, in a real world situation, that should not happen. So it's slightly moved, and we just need to fix that. Well, that's also easy. We can fix it once again using a simple method. So what I'm going to do here is I'll simply just go to mate, and I'll suppress this rack and pinion mate. So select and suppress. Now moving this rack won't move the gear. All right. So right here, it is properly placed, and I'll make it like so right here. All right. With that, let's activate this. So I'll go to unsuppress, and now here we are. So it is no longer touching it, and it is properly moving the pinion, which in turn is moving the gear. So in this way, you can add the rack and pinion arrangement as well as the meshing between gear. The only thing that you need to take care of is the pitch diameter. And if you don't know the pitch diameter, then knowing the gear ratio is really very important before you could just add it. Now let me show you another example where this rack and pinion arrangement can be used in a playful way. So I'll go to window and I'll select another assembly here. Now in this case, as you can see, well, that's just a lipstick. And here, if we rotate this base, this lipstick should move up and down. Now, in this case, we can actually use this rack and pinion arrangement to just replicate the kind of motion that we would expect from this. Now to do that, I'll go to mate and I'll select mechanical and rack and pinion. Now in the previous example, we selected pinion and pitch diameter, but now I'm going to select the second option, which is rack travel per revolution. Alright, so this is the option, but before that, let's select the rack and the pinion gear. Now the rack in this case is this stick of the slipstick, and we just need a straight direction. So here we have this axis that you can select for the straight direction. So just select the axis. Now for the pinion, well, we can select this one. So this edge right about here that can be selected. So this is the edge. So we have selected the pinion as well as this. Now go to rack travel per revolution. So this rack should travel a distance of 120 unit for every single revolution of this base. So that's what we want. And with that, I'll just click OK and OK again. And now let's test it if it's working. So I'll rotate it, and yes, it is. It's moving inside. And if I move it in opposite direction, well, it is moving outside. But we have a problem. I mean, this is not something which you would expect in a real world situation. So it should stop somewhere. Now, to add those physical limitations, what we're going to do is we'll simply add another mate. All right. So maybe I'll just move it all the way up right here, and then I'll go to mate again. Now I'll go to advanced mate. And this is one of the mates which we have already seen, but in this example, I'll just add it. So the mate is this distance limit mate. Select it, and now we'll apply this distance limit mate between this plane and the plane right here, which is this bottom plane. All right, so the distance between that bottom and this lipstick should be 0 at its minimum, and the maximum value is 120. 120 is the height of this base right here, from bottom to here. So that's 120. All right, so now we have set the limits. Let's click OK and see if it is working now. So if I now rotate it, at some point it's going to stop. But if I rotate it in opposite direction, once again it's rotating, but again it will stop at some point. And that's the tool limit which we have set. So here it's stopping at 120, and here it's stopping at 0. So now it's working within the physical limits as well. And that's another example of rack and pinion arrangement.